Hey everybody, I've had a couple questions about number 18 on page 209. A 10-foot plank is leaning up against the wall. At a certain instant, the bottom of the plank is 2 feet from the wall and being pushed towards the wall at a rate of 6 inches per second. How fast is the acute angle that the plank makes with the ground increasing? So the idea here is we're pushing this plank. That X value is a variable. It changes with time. The rate at which it's getting pushed towards the wall was 6 inches, but everything else was in feet. So we have to convert everything to inches. Or what I did is I just converted this one back to feet. So a half a foot is per second, 6 inches. The constant in this problem is 10. And then what we're trying to find is the rate at which the angle is increasing. Hopefully everybody understands what the question's asking for, and there's our picture. Take inventory of all your variables. At a certain instant in time where x is 2, that's what we're going to use ultimately to find our rate of change of the angle with respect to time. Also at that instant, we know that x is changing at a rate of 1/2. We don't know what theta is at that instant, but that's what we're going to have to find first. And then ultimately we need to find d theta dt. Before we get too far into this problem, let's write an equation that relates x and theta, dx dt, and d theta dt. Can you guys come up with a formula that has those variables? That's right. It's the cosine. So the cosine equals adjacent divided by the hypotenuse. The cosine of theta equals the adjacent divided by the hypotenuse, which is a constant 10. I'm going to solve this one for x before I take its derivative. Boom, it's gone. And then it's time to use calculus. Let's take the derivative of both sides, but with respect to time. So the derivative of 10 cosine theta is negative 10 sine theta times the derivative of theta, which is 1, times the derivative of theta with respect to time, d theta dt, just like the chain rule would be. The derivative on the opposite side, the derivative of x is 1, but you just took the derivative of x, tack on dx dt. Anybody have any questions? Sounds like my 6-hour class. Let's throw in some of our values. We don't actually need what the x is in this value because it took care of itself when taking the derivative. We do need what theta is. We're looking what d theta dt is, and we have this as 1/2. Let's find out what that theta value is. We have to find theta when x is 2. So to do that, we can use the cosine again. The cosine of theta is equal to adjacent at that instant in time divided by the hypotenuse. Take the inverse cosine of 2/10. Make sure that your calculator is in the radian mode. If it's not, this is going to go haywire. That's the value that we're going to shove in for theta right there. When you shove that in for theta and solve, d theta dt for me came up rounded to the nearest 3 decimal places. Radians per second. Now, mine actually came up to be negative. Sometimes on these ladders or planks against the wall, if we would have drawn the picture backwards, we don't know if we're pushing this way or that way. But if we were pushing it this way, then our answer would have come out positive. So make sure on these ladder and plank problems that you just test at the end and figure out what the nature of our final answers should be. In this case, the angle was actually increasing, so it can't be a negative. That's all I've got. Remember, if you guys have any questions, just email me, even through spring break next week. Take care and stay healthy.